Very simple way of thinking. It's very fundamental and very simple axioms that just needs very little adjustments in our current physics and science and so on to generate just a little bit of a different picture that opens doors to a whole new way of being. Although this information may seem quite complex, it actually, is very accessible to everyone. And I teach this to 7 years old and to 80 years old, and everybody can get it. So keep your mind open, keep your heart open, and we'll go from there.
I got my first geometry class. It was an exciting time because the teacher went to the blackboard and made a little dot and said, today we're going to learn about dimensions. After he put the little dot on the blackboard, he said, the dot is dimension 0 and it doesn't exist. And I thought, oh, I think I'm going to fail this class because I could see a dot from all the way in the back of the class. So if I could see it, how is it that it didn't exist? Then he did something even more miraculous. He put a bunch of dots together to make a line, called it dimension 1, and said that didn't exist either because it still didn't have volume. Then he put 4 lines together, made a plane, called it dimension 2, said that's the dimension that our comic strip books live in, and he said that doesn't exist either. The teacher then did something remarkable. He took 6 of these non-existing planes, put them together into a cube, and said, now the plane's enclosed volume, this is dimension 3, and that's the one you exist in. And I thought, wait, how's that possible? I don't care if you have 1,000,000 non-existing planes. If you put them together, you still don't have existence. This didn't work for me. I thought, if the dot doesn't exist, the line doesn't exist, the plane doesn't exist, you don't have existence. Most of our math and physics is based on. Our physics and advanced physics, Einstein field equations, quantum theory, all this is based on flat space. And if these axioms, if this fundamental concept is not correct, then most likely what we're going to end up with when we run all these physics and all these mathematics to understand our world is going to be a little tweak. It's not going to be quite correct. I wanted to understand it. I wanted to find a new solution. I had a long bus ride going home, and I thought, I got to figure this out. I was in the bus, and I was thinking, I'm not going to get out of the bus until I got this figured. I didn't know that many philosophers and scientists had grappled with this problem. I closed my eyes in the bus, and in my mind's eye, I visualized myself seeing the bus from above. And I rose further and further, and as I did, the bus started to look like a dot. And then eventually, I rose further, and the country I was in started to look like a dot. And I rose further, and I saw the Earth starting to look like a dot. And I rose further, and I saw the solar systems looking like a dot. And I rose further, and I saw the galaxy looking like a dot. And I thought, oh my God, it's dots all the way up. And then I flew back into the galaxy, flew back into the Earth, and found the bus I was in, and opened my eyes and looked at my hand, and I thought, wow, I wonder what's in my hand. And I closed my eyes again, and I flew into my hand, and I thought, wow, it's made out of millions of dots, cells. And then I flew onto the surface of one of those cells, and I looked around, and it was made out of millions of smaller dots that looked like stars in the sky. And I thought, whoa. And I flew into one of those dots and looked in the middle. Sure enough, there was another teeny-weeny dot in the middle of those atoms. And I thought, wow, it's dots all the way down. And a light went on, and I thought, oh, the way to solve the dimensional problem is to reverse the axiom completely and say the only thing that exists is the dot. Within the dot is infinite amount of division, infinite amount of information. And I thought, wow, everything is made out of dots, and the dots are arranged differently, and that makes up our whole world. Wait a minute. If it's infinite divisions, if it's infinite, how is it that we get finite structure? How is it that we get a finite boundary? In a very simple way, I'm going to show you geometrically that infinities and finite system are actually complementary.
And this circle could be a 3D sphere that contains a very specific space. And in that sphere, or in that circle, we're going to put a triangle, an equilateral triangle. Now, the universe is polarized. And the reason why things are polarized is because they spin. Okay, things in the universe are polarized because they spin. So if you have polarity, then you can accurately have a reverse triangle in that sphere or in that circle. Now, right away, we have one of the most common ancient symbols that we find all around the world. Now, we can continue to add triangles. And now we get smaller stars. Baby stars of David, okay, baby six-pointed stars. We can continue to add other resolution of stars by adding more triangles. Again, smaller stars of David. Every time we create a new resolution, we can define a very specific boundary. This is very important. And here we find a third boundary, so smaller and smaller sphere. We can continue to make smaller and smaller resolution of this geometry. And in fact, if I give this to my computer as a computer code, and I got it to make geometries maybe 5 resolution deep, and then zoom in, and then go 5 resolution deep again, and then zoom in, and then keep doing that, it would continue to do that to infinity. As long as the computer had power and chips would keep working in there, it would continue to make boundaries for thousands of years. However, I would never, ever, ever exceed the first boundary that I've set for myself. Within a finite system, I've demonstrated to you right now that you can create infinite numbers of division. Infinite numbers of sets of information. In a boundary is the possibility of infinite division. And thus, infinities and finite structures are complementary. Taking these principles and applying them to yourself, that maybe within the confine of the finite structure that you're in is the potential of infinite division, the potential of infinite amount of information. Philosophically, that has a very powerful impact. To be very similar to what many of the masters that have walked the earth have talked about. That within is God, the kingdom of heaven, infinite boundaries, and so on.
So you don't need to even have a spiritual concept of your infinite nature. It's actually the way you're made, if this is true.
This complementary fractal condition could change the fundamentals of physics.
At first, when we had our first microscopes, when we saw cells, we thought, oh my God, those are so small, they gotta be the smallest thing the universe does. And then we found that those cells were made out of atoms. And the atoms are so small, we thought, oh, those are gotta be the God particle. Those are the smallest thing the universe does. And then we found that those atoms have nuclei in the middle, protons, neutrons, and those are teeny, weeny particles compared to the size of the atom. The universe goes all the way down to that size and then stops and says, okay, that's small enough, I'm not doing anything smaller. However, then we found quarks, and so on. And at this point, we're building accelerators that are enormous, an extraordinary device that accelerates particles at faster and faster rates to get smaller and smaller particles, thinking every time that we're going to find this fundamental particle that can no longer be divided. However, every time some physicist somewhere write a new equation saying, oh, maybe there's another energy level, and then next thing you know, we're building a larger accelerator to try to find it. And now we're looking for things that are billions of times smaller than an atom. But based on this concept that we've just learned about, we would know that this can be done to infinity, that you can always get a smaller and smaller particle if you could get a larger and larger accelerator. So what is this really telling us about the universe? I think that a more worthy exploration would be to stop looking for a fundamental particle and start looking for a fundamental pattern of division. Because if we could find a pattern in which the universe divides, then we would have the key to creation. And that could be really useful. When the balloon expands, the lungs contract. So for every action, there's an equal and opposite reaction. Some of the first laws of physics. In our current model, the universe is expanding, but nothing is contracting to make it expand. So how is it that the balloon can expand if you're not compressing air into it? For me, it was a crucial moment. It had come from earlier experiences when I was young, where I realized that, you know, there's an external world to my experience, but as well is an internal world to my experience. And I thought maybe the boundary conditions of the division of the universe are the result of the relationship between the outside world and the inside world. And that the two are like colliding waves, like standing waves that produce boundaries. If I was to point at something that connected all things, what would that be? If I could choose just one thing that connects everything, what would that be? Is space. Space is everywhere, between galaxies, between stars, between planets, between cells, between atoms, and even the atomic structure is made out of 99.99999% space.
Space. But they don't feel very spacious. I mean, it's pretty solid. But what's going on is that there's all these fields interacting and they don't necessarily are in perfect resonance and they make boundaries and so on. And so it feels like it's solid, but it's mostly space. It's basically a field dividing the vacuum. Oh yeah, maybe we should look at the vacuum. And the space divides itself and then we see it as finite boundaries. Maybe the space is the infinity and the boundary is the finite structure. The field is the finite structure.
All the material world that you think is so solid is actually mostly space. What you're experiencing as your reality, what you call the material world, is actually 0.0000001% of what's there. Yet we spend most of our time paying attention to that part and forget to look at the space. For me, earlier on, it was crucial that maybe it's the space we should be looking at. Maybe we should pay attention to the 99.9999999%. Maybe objects don't define the space, but space defines the objects. Well, if that was true, and if the vacuum, if the space was connecting all things, since all things radiate in the space, and if the space is the source of all things, then that space could not be empty. What we call the vacuum, what we call so-called empty space, could not be empty. It had to be full. And it had to be infinitely full. Very, very dense in any case. That the vacuum is not empty, that space is actually a fluctuation that may be actually the source of our reality. Usually what's used is a fundamental constant to cut the number. In this case, what was used was the Planck's distance. The Planck's distance is supposedly the smallest thing the universe does. It's the smallest wavelength the universe is supposed to be able to do. Do I think that the Planck's distance is the smallest thing the universe does? No, I think that the Planck's distance is a boundary condition that is a fundamental boundary in relationship to our experience. But I think that there's further definition, there's further structure below the Planck's distance. In any case, using the Planck's distance, which is 1.616 multiplied by 10 to the minus 33, extremely small, billions of times smaller than an atom.
If we put the number of these little dots in a centimeter cube of space, of vacuum, we will have a finite density for the vacuum fluctuations, for the vacuum density, the energy in a vacuum, in a centimeter cube of vacuum. So here it is. They took a centimeter cube of vacuum. They took a Planck's distance, bitty teeny point, and they stacked them into that cube. And then calculated how much density of these quantities would there be in there to get a finite number. The result is 10 to the 94 grams per centimeter cube.
Time you add a zero, it makes a big change. Imagine that you have 50-some zeros and you keep adding. At 93 zeros, right, you've got the density of the vacuum.
If you want to get an idea of what density that means, imagine you have a centimeter cube of space that has all of the stars in the universe condensed into it. Like all of the stars we see with the Hubble. Okay, all the galaxies, everything we see, we just put it all in a big trash compactor and we just squash it all up into a centimeter cube of space. You still wouldn't have the vacuum density. You still would be short from the density of energy that is calculated to be in the vacuum at the quantum level. I started to see that maybe, just maybe, everything we see in the universe is just division of that energy density of the vacuum in various scales. Well, okay, if this is true, then if we look at a large scale in the universe, we should start to see very specific divisions. We should start to see structure. If the vacuum is dividing under very specific structure, then we should be able to see it. We should be able to calculate it from what we observe. What we did is we took the radius of objects, okay? And so here on the in the x-axis is the radius. And here is the frequency of these objects, the fundamental frequency of these objects in hertz. We placed the data point for the universal, the 10 to the minus 17 is the universal frequency based on our calculation. And then we place the next data point for the for quasar, and it surprised us. It was a fairly good linear progression from universal size. Then we place the data point for galactic centers, so we're getting smaller in scale. And again, an average galactic center oscillation rate and radius. And we place the data point, and again, linear progression. Then we place a data point for solar dynamics, stellar dynamics, and we got a linear progression again. Then we went all the way to the atomic level with the radius and fundamental approximation of frequency for X-ray emission. And we got a data point that was a perfect linear progression again, but this time across the boundary of quantum theory into the atomic level. So now we went from cosmological object to quantum theory level. And then we went all the way down to the Planck's length and placed the Planck's length. And sure enough, the progression was perfect. The other thing we noticed is that if you take the distance between the data point, which is kind of nice, it's sweet, and you divide them, you always get very close approximation to the phi ratio. The phi ratio is 1.618 and is, and goes to infinity. It's typical to find it in nature everywhere. You find it in flowers, in shells, in pine cones. You find it in the way tree divides. You find it in your body. There's a phi ratio between the end of your finger and the second part of your finger, and there's a phi ratio between the second part and the third part and your hand, relative to your fingers, and then your fingers and hand relative to your forearm, and your whole body is built like that, and so on. And so you find it in nature everywhere. So to find it on a scale that's so large, well, we were happy to find that if you place that data point for the biological cells on the graph, it would bisect the graph approximately in the middle. That is, the biological resolution is the link between the large and the small. You are the event horizon, and you are the data transfer boundary from the extremely large to the extremely small. Isn't that what you do? You gather information and transfer it to your internal self, which in this view has infinite boundary potential. Thus, you're transferring that information through your boundary to the infinite of the universe within yourself. When you place all that matter in Einstein field equation, the result is that the universe is too dense for light to escape it. That is, we live inside a black hole.
There was another data point that was interesting in the scaling law. The atomic level is in between the universal size and the Planck's distance. Now, as we saw, the universal size can be considered a black hole. It obeys the Schwarzschild condition. And the Planck's distance obeys the Schwarzschild condition. So having the atom right there on that linear progression started to indicate that the atom may be a black hole itself. The division of the space can be done to infinity. If an atom has subatomic particles that are made out of sub-subatomic particles that are made out of sub-sub-subatomic particles and so on to infinity, and each one has a mass, then there's infinite mass at the center of atoms. And to me, very early, I concluded they must be mini black holes. From this conclusion, I extrapolated that there must be a black hole at the center of all galaxies. I said that very early, almost 17 years ago. However, at the time, there was not much data about the center of galaxies, so many physicists thought this was improbable. Eventually, we got more and more data about the center of galaxies, and we found that there is a black hole at the center of what seems to be every galaxy we observe. Could we approach the atom as a mini black hole? Eventually, this is how I solved it. And it is the crux of the unification theory that I'm bringing forward. What I did is I said, wait a minute. We have a density of the vacuum of 10 to the 93 grams per centimeter cube. Is that considered when we look at the atom? No. Actually, the vacuum density can be measured in laboratory and has mechanical effects. How much of vacuum would be present inside the nuclei of an atom? Would that energy be enough to make the nuclei of an atom a black hole? So I looked at the proton, which is at the nuclei, and I started to extrapolate how much vacuum would the proton volume still contain, knowing that there's 10 to the 93 grams per centimeter cube in a centimeter cube of space. How much of that vacuum would still be present in the volume of a proton? I calculated the volume of a proton and found that there is still 10 to the 55th grams in a proton volume. 10 to the 55th grams of vacuum energy is still present in a proton volume. Where did we see that number? 10 to the 55th gram is the mass of the universe. There is the mass of the universe present in vacuum fluctuation, in vacuum density, in the volume of a proton, which is a very, very small entity. This confirms something fundamental to me. It confirmed that the vacuum is truly the thing that connects all things. It showed that everything is entangled and everything is one. And it showed it mathematically. It's one thing to say everything's one, which is some things you find people saying in spiritual worlds. However, this actually proves it. Space is what defines matter, not matter defining the space. All matter emerges from the vacuum and returns to the vacuum.